Hello and welcome to our webinar today. Our topic today is digitalization as a booster for an efficient cooperation between OEMs and workshops. I will make a short introduction. My name is Oliver Socher. I'm the product manager for the TDX product. And with me is Markus Linsenmeyer. He is our software engineer. We have some points that we want to discuss with you and want to show you. We have a short agenda here with a few points. The first point is challenge in collaboration with workshops. As you can see on the slide, there's the ecosystem outline and the worldwide usage of after-sales tester. As you can see on the left side, we have the OEM, and on the right side, we have the workshops. Back in the days, it was common that the tester was burned on a CD and distributed to the workshops by post actually. And now, the usage has strongly been different. The tester is been distributed. It's been distributed to the server, as you can see. The workflow also. From the tester goes from the OEM to the workshops to the server, and the information goes back from the workshops that's in the field worldwide, as you can see, back to the OEM. So the OEM can collect all the data back from the field, so he can collect all the information that he's needed to develop the tester better. The challenge rollout, worldwide distribution of after-sales tester. As I mentioned on the slide before, the distribution of the tester has been now going through the server, and it doesn't depend where the workshop is. As you can see, it could be everywhere, and everywhere can it be distributed. It's in the tester software. It's not only the tester, it's also the VCI firmware, the diagnostic information, the repair information, and the ECU, and also all the updates that the workshops also through the server from the OEM. What is also a very important part for the OEM and for the workshop, the workshop should plan very fast the repair and the maintenance for the car when the customer is at the workshop. The workshop needs to find the direct part at the workshop, and if the part is missing, so he can look for the part in the tester, and the tester is connected to the server with the OEM. So actually, the workshop manager can find this part much faster, and the diagnostic routine result is also very fast. So that's very important. Spare part localization as a diagnostic tester refers to the tester's ability to identify, isolate, and pinpoint faulty components or replaceable parts within a system, vehicle, or device during after-sales service and maintenance. As you can see, what I also said, warehouse logistics and the ERP systems that are connected by the manufacturer. I can say here manufacturer, the OEM. The next slide, what we can see here is increasing diagnostic quality. Know your user, add initial information. What is very important for the OEM, that the OEM should know should have more information from the field, from the mechanic, so he can improve the tester. To increase diagnostic quality, you need structured processes, high quality diagnostic data, OTX-based guided diagnostics, smart test coverage, AI-assisted analysis, strong feedback loops, and skilled technicians. What you can see also on a major part, very interesting major part, is reduce warranty costs. As every workshop wants to reduce their warranty costs and want to have their repair very quickly. What we have here is that predictive maintenance engineering enforce structured diagnostic paths, improve diagnostic data quality, prevent wrong part replacement, fix software first, close the field feedback loop, lower parts replacement costs, reduce labor hours, what's very important for the workshops to repair the car faster, and so the customer could have the car faster in his hands, fewer repeat and go-to-wall repairs. In this slide, I'm talking about master increasing system complexity. The point is remote support. Remote support transforms risking system complexity from a risk into a competitive advantage by connecting data, expertise, and diagnostics in real time. Experts can support multiple vehicles workshops remotely, no waiting for one on-site specialist, reduce vehicle downtime. Remote experts see then live data, logs, and measurements. Second-level diagnostics before parts are replaced, guided decision-making instead of guesswork.
Okay, and now we'll try to show how we try to master those challenges. So what we see here is a typical scenario as we currently see it in the field. So the data from the server that's sent to the workshop is usually tester and VCI software, diagnostic and repair information, ECU software, or even the spare part catalog. The other way around, the tester will send vehicle status and reports, and diagnostic results. It will also send which functionalities have been used, and the server will receive user feedback directly. Other than that, the server will also provide a remote use case as a broker, so you can do remote diagnostics directly on the tester machines. Some typical server features are taking user feedback, software distributions, repair content distribution. Additionally, the server connects to a variety of third-party systems like ERP logistics integration, identity providers, report evaluation, and there's also a plugin mechanism for any customer API that you want to integrate into the server. And that's how we try to master today's challenges. We're reducing warranty costs through fully integrated diagnostic troubleshooting. We are challenging the rollout through a proper release process and region-wide rollout. We are mastering increased system complexity by integrating OEM IT into the TDX server directly. And we're helping with the spare part localization by integrating, for example, 3D models and existing purchasing systems into the TDX server. Now we will try to display how you can increase efficiency through some examples. So let's go with the tester rollout. For the tester rollout, you first implement some fixes. You create a release. After that, you deploy that on the cloud. You push, for example, safety relevant fixes to the cloud. And then you define the regions and schedules which should receive the updates and when. And after that, you have an automatic worldwide rollout. Another example is the tester usage in the workshops. So when the technician starts the tester software first searches for updates in the background and downloads them automatically. Meanwhile, the technician can execute the diagnostics and repair. For example, like a guided diagnostic troubleshooting. The results are then automatically transferred to the TDX server, and the results are then available for later statistical analysis, but more to that later. Last part of the report cycle, as we call it, is the data analytics. And the server provides APIs to filter and extract data records directly from the server into third-party tools. There you can then compare issues in models or components and model years and generate information about quality trends, improve diagnostic functions, etc., etc. And collecting that kind of data is the basis for every kind of predictive maintenance we want to see in the future.
Thank you, Marcus. The next point that we have on our agenda is Softing TDX as a solution example. Please see here, that's our universal toolbox from Softing TDX. On the left side, you can see Softing TDX Studio. That's a tool that we are using for diagnostics, repair procedures, user interface. So you can start to build your tester with the TDX Studio, design it in corporate CI. Well, everything is manageable. All the data that you written in the studio, you can manage it through the server, whereas the IT integration, user management, and rollout. And if you see on the right arrow, you see the TDX Workshop. TDX Workshop is been distributed to also in the field to the workshops, so the workshop managers can use the tester to maintain their vehicles. What's very also important in our products is the TDX server. As you can see, in the middle is the TDX server. And the TDX server has a few interesting features. The first one, what you see, there's the remote support. The workshop manager can send information, or he has a problem with a car that he doesn't come further with the issue. He can send the information to the server, and the server is connected to the OEM, so the OEM or the technical call center can help him. On the left side, we have also Active Directory. So roles and rights been given to the testers. So some of the testers have different rights for different persons that are working in the workshop. Also, ARP part numbers. There you can, through the TDX server, you can connect the API to an ARP system, to a logistics of parts, where you can find the parts, and to the server you can order by the OEM the part much quicker than before. Also CRM licenses, that's also a one issue. On the right side you can see a diagnostic tester where he sends the reports to the server, to the OEM, and also the diagnostic projects and be sent to the tester. And what's also very important at the workshop is the vehicle history, the big data and quality assurance. If a car is at the workshop and it's the first time, the workshop manager can check all the vehicle history from the car back in the days, what was repaired. So this will help him to maintain the car better. As you can see here, what I also mentioned before in the slides, that's the TDX Studio. So you can design your own tool or tester. You will write their repair procedure, diagnostic parts, and design the complete the tester. What you can see on the right side, we have some points. We have the corporate design, what I mentioned, access path for mechanics, symptoms, vehicle ECU, configurable graphical user interface, business logic optimization guidance, helping content, images, videos, PDF diagrams. So everything is possible in this great tool.
Okay, and for the next point, we will give you a live demo of the TDX server. And specifically, we will go in depth for the points rollout, management, issue management, and vehicle reports. For that, let me switch to the TDX server. Okay, what you can see now is at first the dashboard of the server, where the administrator can configure a few things to see directly what's going on. And every user can configure that for themselves so that the use cases they are having on the server are visible on the very first page they see. The first thing I want to talk about is the rollout. Earlier, we were already mentioning that we have a release process, which you can adapt to your needs. As we can see here, we have currently 3 releases on this server. We have an old one which is already deprecated and should not be used anymore on the field, but for historical reasons, it's still kept on the server. Then we have the 1.1.2, which is currently released and which is the version that is used worldwide in the field. And you can also see we have a test version that is currently under test by beta testers and developers. This is only available to a certain group of people, which of course you can adapt. So you can define alpha and beta testers on this server and then define which people get which releases. You can also define the regions which receive a release at which point in time. The second topic I want to talk to you about, let's go to the issue management. So with this tool or with this whole tool chain, the TDX workshop can send feedback directly to the TDX server, which can then be viewed by your developers. And after some time, you will notice that every time the user sends feedback or issues or error reports, you will not have all the data you need to, for example, fix the bug. We try to challenge this situation by sending all the information that you need in one go. As soon as the user uses the tester to send a feedback, you get all the log files, you get all the additional information that you need, you get system information, you get screenshots, whatever you want to have, you can get this into the feedback. Let's, for example, take a look at the feedback that we see right here at the top. NASCAN doesn't detect the vehicle. We click it, we see that you have a description where the user can put any description he wants to, for example, steps to reproduce if it's an error or a bug. You have attachments which you can define yourself what your tester will send in attachments. And then you have a comment section, some relations. You can subscribe these issues from the tester directly or here in the system, which means that you have a complete issue management system integrated into the TDX server. And the last point I want to talk about is the vehicle reports. So for the first place, the TDX server is just, let's say, a data pool which collects all your vehicle reports. As we always say, it's important to get these reports as soon as possible, even if you cannot evaluate them yet. Because for big data analysis and later predictive maintenance, you need those reports from the past before you even start working on the analysis itself. So the TDX server saves all the reports. Of course, we can connect to any file management system in the back. And we also provide some APIs that you can retrieve those reports from the TDX server. Then you can analyze them in any third-party system you like. Okay, I think that's about it, what we wanted to show in the TDX server.
Yes, we have a summary at a glance. As you can see on the right side, the products that we are using and having. This TDX Studio, TDX Server, what Marcus showed us, and TDX Workshop. TDX Workshop, as I mentioned, is a tester that's in the field. Here are 3 points, but you can see it's increasing system complexity meets higher rollout frequency, efficiency targets to be fulfilled, Service Cloud as a central information node, masters requirements already. What are the benefits? It's a fast worldwide rollout, automated reflow, and cost saving through fast reactions. Questions and answers. Yes, we have here some questions. Let me take the first question that was here written. How long does it take to develop an after-sales tester from scratch? Well, of course, it depends how fast you want to start. That's the first point. The second point is it's to take a look how many ECUs are in the vehicle inside. So what we also when you talk with customers, we often make a POC with the customer. Of course, the POC is started like 3 months, 4 months, and to develop the complete tester. As I mentioned, it depends on how many ECUs are built in the vehicle. But as this is the work, I do make an official rollout and make some pen tests also. It takes over 1 year to make a full-blown tester. We have a second question. Marcus, do you want to overtake?
Oh, yes, of course. So the second question was, can we deploy the server on-premise? That's a very good question. We can deploy the server on-premise or on an Azure cloud, for example. We could also deploy it on an AWS cloud. But basically, we try to support as many rollout options for your server as possible. Okay, I think we have, yes, we have another question.
We have another question, and I will overtake. Can we brand the tester in our corporate design? Yes, of course. We do it for our customers. So our VCIs are branded by by us for the customer. So that's not a problem. Also, the tester can be branded with the CI from the customer. So everything is possible. We're very flexible with our product. So the answer is yes. With the VCI, the VCI can be branded, and also the tester can be branded.
I see another question. Which of the usual standards are supported by the after-sales solution? Okay, yeah, let's go there. So our complete tool stack is based on standards, which means that every part from the vehicle communication up to the diagnostic communication language are standardized. We're talking about ODX, we're talking about OTX, and all of the parts that are used in our tool are standardized, like the D servers running on the MCD3 API, and the DPDU API is also another standard that is common in our field. Then I think we can close, we can finish.
Yes. Thank you for all the viewers that joined our webinar for this interesting topics what we presented today. Thank you, Marcus.
Thank you, Oliver,
for having you here with me. And yes, thank you very much.
Thank you for your attention.